All right, hello. So welcome. I'm going to try to get through this common assessment review as quick as possible and so that you can see the answers. Problem number one, find the degree of each polynomial. In order to find the degree of the polynomials, we need to put it in standard form. So standard form has the highest degree, or the base variable with the highest exponent. That would be the way for me to describe that. And so d to the fourth power is the highest of these terms. I can also combine like terms. Like terms here, I have d to the 1 power and 3d to the 1 power. So I can combine those. That's going to become plus 17d. Now my highest degree is 4, so the degree of this is going to be 4. All right, that's my answer. Problem number 2. Sorry, cat, move, stop. Sit. Sorry about that, my cat's getting in the way. Problem number 2 is a monomial. There's a special rule about monomials. If we remember all the way back, monomials, if I have more than one variable, I need to add the exponents. If more than one variable, I'm not going to write that up, that's too much. More than one variable, you have to add the exponents. So this first exponent is to a degree of 3, or exponent of 3. Y is to an exponent of 1. So 3 plus 1 will give me 4. So this one here is degree of 4. All right. Problem number 3, just like we did with problem number 1, I'm going to put it in standard form. X squared is my variable with the highest exponent, so that's going to go first. My next highest exponent is 4x. Then last needs to be 1, because 1 is essentially 1 to the 0 power. This is x to the 1. So as you can see, I'm ordering this from largest to smallest. Now, because this is not a monomial, I'm not going to do anything but look at the highest exponent, which in this case is 2. So this is a degree of 2. Problem number 4. All right. Problem number 4, I'm going to look at my numerator first and see if I can take a GCF. I have x plus 7. The GCF of that is 1, so I can't really, well, we can just say 1, x plus 7. We can do that. Let's do that. Now, the numerator, or the denominator, I have a quadratic trinomial. So that means that I can factor out a GCF. So when I factor out a trinomial and it's a quadratic, I'm going to have two binomials here. And I'm going to look at my C value. All right, since my A value is 1, I'm just going to look at my C value. And my first two terms are going to be x here, because x times x are going to give me x squared. Now, when I look at my factors of 7, the only factors of 7, because 7 is a prime number, are 7 and 1. If I add 7 and 1, that will give me 8, which is what we want here. We want the sum of our B value. Okay? Now, I'm going to look and see which ones I can cancel out that's in my numerator and my denominator. I can cancel out the x plus 7 and the x plus 1. So then I'm left with 1 over x plus 7. X plus 1, sorry. Now, I'm not done here quite yet. Need to do one more special step. Specifically with factoring fractional expressions, okay? When I'm factoring this as 0, my denominator cannot equal 0. Okay, denominator cannot equal 0. So in order to do that, that means that we're going to be looking at our original expression, which is that expression, okay? But now I can look at the factors, x plus 1 and x plus 7, to determine what two x values x cannot be, okay? For my simplified form. In order for me to do that, I'm going to do x plus 7 is equal to 0. Well, what plus 7 will equal 0? Negative 7. Negative 7 plus 0 is equal to 0. Negative 7 plus 0 is equal to 0. So x cannot equal negative 7. Same with x plus 1. Negative 1 plus 1 will give me 0. So x can also not equal negative 1. That is my final answer. Okay? Simplified form of, oops, sorry, that was the cat putting his paw on my screen. Sorry, no pause on screen, Walter. All right, moving on. In this review guide, let me continue that problem number 4. All right, if I were to plug in either of those values, -7 or -1, into my original expression here, it would make that denominator equal 0. So that's why I can't use that. So 1 over x plus 1 is the simplified form of our original expression, and the values of x excluded are -1 and -7. Problem number 5. We're going to simplify problem number 5. I can rewrite this. Let me put in space here. Just so that I have room here. Cat, stop. Now, I can rewrite this as 2 times the square root, and I'm going to replace 12 because 12 is not a perfect square. I'm going to replace it with a divisor that is a perfect square. 4 will go into 12, so that's going to be 4 times, not 2. I'm tired. 4 times 3. And then y to the 5th, I'm going to rechange that and write that because, remember, when I have the square root of a radical, and let's say I have this number here, 1. This index number, I'm taking my index number, essentially when it's the square root, that index number is 2. Okay? So when I rewrite this in expression form, this is going to be a to the 1. My exponent goes to the numerator, and then my index number, this number there, goes to my denominator. So the same idea goes with this. So when I talk about that, that would become y to the 5 over 2. But 2 will not go evenly into 5. But I can change this to be y to the 4th, which 4th power is divisible by 2, and I can write y to the 4th times y to the 1 power. That would give me y to the 5th. So I'm replacing y to the 5th with y to the 1 power and y to the 4th. So now I can take the square roots. So 2, I keep the 2, because that's 2 times. The square root of 4 becomes 2, so now I pull out the 2. I can't take the square root of 3, but I can take the square root of 4. Again, just like over here, that's going to become 4 over 2. So when I take 4 divided by 2, I'm left with y to the 2nd power. Then, inside the radical, for my radicand, I'm only left with 3 and the value of y. Now, I have 2 times 2, so I need to rewrite this as 4y squared, square root of 3y. Okay? Problem number 6. Listen, I made a typo error. This value is supposed to be b, because I wanted you to find b and talk about finding how to find b. Okay? So let's talk about how we can find b if we don't know what the value of b is, but we know what one of the factors is. Now, if you don't know what one of these terms are, you're going to have to, in order to find a specific term, you're going to have to know one of the factors, because otherwise it could be multiple values. Okay? Now, if I know that the factor is 11n minus 6, we don't know what our other binomial is. But I know when I take 11n and I multiply it by that number there, I know that that's going to give me my value a. And so that's going to give me my first term. So in order for me to do that, I'm going to take 55, divide that by 11. That 55n, divide that by 11n. That's going, or 55 squared divided by 11n. That will give me 5n. So I know my first term in here is going to be 5n. Now again, just like the second term, I know also that this is going to be negative, because a negative times a negative is going to give me the positive there. Right? Now, I'm going to do the same thing. 6 will go into 12 2 times. Okay? Now I found my two factors. Now I'm going to need to FOIL. So I'm going to do 11n times 5n. That will give me 55n squared. 11n times 2 will give me minus 22n. Negative 6 times 5n will give me negative 30n. And negative 6 times negative 2 will give me positive 12. Now I'm going to simplify this. This is going to be 55n squared minus 52n plus 12. And as you can see, we found our b value, which is 52. All right? So the b value is equal to 52. That is our answer. Problem number 7. Listen, don't get scared by that second variable. If we look, when we have t squared and that a value is 1, I know that I'm going to do t, and I'm going to put t there. Okay? I'm also going to have a positive and a negative because we have negative 30 and we have a negative 13. Okay? Now, if I notice, look, I have a t squared, and I put those there. When I multiply them, that's going to give me t squared. But then when I talk about the other factors and I FOIL, that's going to end up giving me a single value of t. So I know if I put s here in my second term, I know that when I multiply that and I FOIL that, that's going to give me the s here and the s squared. So now I can just think about the factors of 30 that will add up to 13. Well, 15 and 2 will give me 30, and 15 plus negative 2 will give me 13. So this is going to be positive 2s and negative 15s. Okay? Problem number 8. I'm going to go and finish those up. Well, let me do number 8, and then I'll start the next video. Let me do 8 real quick. All right. Number 8. We want to look at the area for the shaded regions. That is base area is equal to base times height, or length times width. So that's going to be x plus 3 times x plus 3. So that's going to be x plus 3 squared. That means that is x plus 3 times x plus 3. Minus the value of this area squared. So x times x. So that's going to be minus x squared. Now, I can either follow these like normal, or I can look at, I know that a plus b squared is going to be equal to a squared plus 2ab plus b squared. So then I can rewrite this to be, let me do a different color. This is going to be my a value is my first term. So that's x. So that's going to be x squared plus 2 times my a value, which is x, times my b value, which is 3, times 3, plus my b value, which is 3, squared, so that's going to be 3 squared, minus my x squared. So I factored those, I FOILed those out. Okay, no, I didn't factor, I FOILed those out. All right, I'm simplifying them. Now that's going to give me x squared plus 6x plus 9 minus x squared. Okay, I got the x squared right from here. The x squared from here, whoops, didn't mean to do that. X squared from there is the x squared there, okay? This problem here, this here is this, all right? Now, I can cancel that one and that one because I have a positive and a negative. So my final answer is 6x plus 9. Now, the reason that I don't simplify that, because I could factor out a 3, and that would give me x plus 1, okay? And in reality, either one of these is correct. But in terms of talking about a side length and talking about the area and simplify to the area, because we're just talking about the area of the shaded region, if I want to find out the shaded region, I just need to plug in that value because this is equal to, so because I'm sitting here saying that this is equal to a. So this value, 6x plus 9, is equal to the a, which is our area. Okay? So this is our answer, not this. Not this. Okay? All right, I will go and finish up the video in the next questions.